So the fourth of our 6 application models in this series of videos is on assignment models. The template for the textbook example again is contained within the reading subfolder of the 05 underscore integer underscore opt folder as usual. Although I'm not going to go through the 8 chapter 15 exercises in either videos or classes. There are great examples you should do on your own as part of your chapter reading. So the textbook example assignment model is the Paul and Giovanni Foods on pages 530 to 532, where this company must decide where to locate exactly 2 distribution centers from a list of potential candidates, and then assign each of its customers to exactly one of the 2 DCs while minimizing the total sourcing costs. Although this example is similar to the set covering models we described earlier in the previous video, please note that the major difference lies in the fact that the potential service locations are not a subset of the customer locations as they were in the previous few examples of the last video. Okay, similar to the set covering problem with 11 major cities in lect 5 underscore set underscore covering, right? This guy here from the previous video. The decision variables are binaries on DC or distribution center locations, as well as customer assignments to selected DC locations. The key constraints are again the fact that each customer assignment row has to be less than or equal to the DC location row. So it's the same as it was in the set covering example from with these 11 major cities and servicing them from 3 locations. So these constraints are again necessary to force the assignments of customers to selected DC locations, just like in the previous set covering problem. The difference again is that DC locations are not part of the customer location set, but the same logic still applies. In addition to these assignment constraints, quote unquote, we have the constraint on the total number of DCs and unique assignments, i.e. each customer is assigned to one and only one DC. The objective is to minimize the sum product of the sourcing cost matrix with the customer assignment matrix, and all the decision variables are, of course, binary 0 1s. Again, all this is in a Paul and Giovanni Foods.xlxx, so please note and check it out on pages 530 to 532 in the textbook chapter for 15, of course. So our example of the assignment model is similar, with a slight twist due to the fact that some of the machines can process more than a single job at a time. Okay, but each job must be assigned to one and only one machine. The objective is going to be similar to the Paul and Giovanni model, which is the sum product of the time matrix with a job assignment matrix. Okay, and the setup, as you'll see once I open up the job assignment lect 5, is very similar to the Paul and Giovanni model. Okay, we'll manually assign. So this is the time matrix first here, right? This is the machine capacity. There's a couple of machines, 2 and 4, that can process more than one job. But each job has to be assigned to a single one and only one machine. So we're going to do some manual assignments. For example, we could look at again the minimum time, minimum processing time, and choose job 2 to be assigned to machine 1, and then maybe job 1 to assign to machine 2. But we could also have job 4 assigned there, right? And then the third job would be, say, assigned to machine 3. Okay, and then machines 4 and 5 would not have anything to do, so it would be all zeros. Okay, so in this case, number of jobs on the machine would be just simply a sum of zeros and ones. Again, I'm not writing zeros, they're going to end up there anyway, and then copy that down, so you will see how 2 jobs are assigned on machine 2, which is okay because it's within its capacity. On the other hand, each job has to be assigned on one and only one machine, so the row at the bottom has to contain all the ones. And again, just like with the Paul and Giovanni example from the textbook, the objective is the sum product of all the machine times, jobs on machine times, with the actual assignment of jobs to machines. Okay, which in this case, I think this is in minutes, 15 minutes. Okay, so Notice that again, machines 4 and 5 in this example are not used at all. To set up the solver, we're going to, at least the current setup, right? To set up the solver, what we'll do is we'll go and choose cell B24 as the objective to be minimized. Okay. For the variables, we'll have the, of course, assignments of jobs and machines, which also have to be binaries. Okay, and then we'll have the number of jobs scheduled on the machine has to be less than the capacity of these machines. And then finally, we're going to have the machine is scheduled on exactly one machine constraint at the end. Okay, make sure you have the LP quadratic problem. I don't think that variable constraints make any difference. And we'll see where we can improve the time of 15 minutes, okay, by reassigning, some of the machines. We still have some of the jobs in different machines. We still have jobs 1 and 4 on machine 2, job 3 on machine 3, but now we have job 2 on machine 4, okay, rather than whatever we had before. I think it was machine 1, which obviously reduced the time by 1 minute down to 14. And you can see that the machines 1 and 5 don't have any job scheduled on them. Each job is scheduled exactly on the machine. Capacity constraints are there, and this is the optimal solution. So we're going to save this, switch back to the presentation, and pause.